In this video, we'll be discussing about Paal synthesis of pyrrole, thiophene and furan using 1,4-dicarbonyl compounds. So these reactions are pretty simple. So have a look at these reactions. These are the main reactions. We'll discuss the mechanism. So take a look at these reactions. Okay. First up, we will start with pyrrole Paal synthesis of pyrrole using 1,4-diketones. So let us discuss its mechanism. So you have your 1,4-diketone. You have your amine. Okay, I will name it as R3. So it's going to attack this carbonyl carbon, and the bond opens up. Very simple. You just need to get a knack of few things. What is happening? So this is ammonium. Here. H R3 H. This is ammonium R2 and 2 minus. This will get protonated to give you hemiaminal. Again, protonation and deprotonation happens. Deprotonation of this particular proton and protonation of this oxide ion happens to give you the lone pair here attacks this carbonyl carbon. This is your hemiaminal. So protonation of this oxide ion happens. Next is your double condensation. So these two groups will condense and 2 moles of water, 2 molecules of water is eliminated to give you an aromatic pyrrole. Okay, and there is an R3 here. Okay, so here what happens in this step, again there is a protonation and deprotonation step. So this will get eliminated, and here this oxide will take up a proton, or you can just show that this is taking up yellow color for that proton. Okay, so that was your pyrrole synthesis of Paal pyrrole synthesis. Fine. So next is your Paal Furan synthesis. So in this Paal synthesis of furan, so this is an acid catalyzed furan synthesis. Yes, it proceeds by protonation of one carbonyl group. So I have here two carbon. So there is a protonation that happens to the first. Okay. Now this carbonyl group will undergo ketoenol. This ketone group will undergo ketoenol tautomerization to give you okay. So what you get is a cyclization occurs here. So the cyclic product is as follows: carbon and deprotonation. This is your hemi acetal. So protonation of this particular oxygen. The next step is base abstracts this and this OH leaves, or of course there is no base here. Instead of the protonation step here, what can happen is, okay, maybe a simple condensation can also happen here. Okay, so this group can condense OH and H to give you your so this is your furan that you have synthesized, Paal furan synthesis. The next is your Paal synthesis of thiophene. So this is also very easy. So there is 1,4 diketone again. The initial diketone is converted to thioketone using sulfurizing agents. Okay. So it could be P2S5 or P4S10. These are all sulfurizing, and there's something called as Lawson's reagent. So which is so this is your Lawson's reagent. So how this step happens is quite interesting. So I'll just show you here. Suppose this is your ketone group and this is your okay. So this is your I'm just showing suppose the reaction is happening between this ketone, okay, and this P double bond S group. So that's what I have shown here. So how that happens is first oxygen will go and attack this. So it's a mutual bond opening to form a quaternary ring here to give you a quaternary ring cyclic. So you end up next step what happens, as I have told in class also, oxygen has an unusual affinity for phosphorus. Okay, so this bond will go away with phosphorus and this bond will become C double bond S, and this is explained using Hassab theory, which we'll study in further classes. Note that phosphorus is in +5 oxidation state and therefore this oxygen has an affinity for phosphorus here. Okay, this has to do with something called as Hassab. So you end up getting your what was the ketone, you end up getting thio in sulfur in place of oxygen. Fine. So now what happens? So this is what you have ended up getting. So you have your the protonation of this oxygen takes place. It's supposed to be charged. This into the next step is there is a so this bond falls back. C double bond is this double bond attacks here. So there is a deprotonation that happens that will result in cyclization. Next is simple condensation of this to give you thiophene. So that was your. So again, one more thing you need to know is here is most sulfurizing agents are strong dehydrators, and they drive the completion of products. Okay. So that was your Paal synthesis of Pyrrole, Furan, and Thiophene. Thank you.